Hi, I'm Parker Wright with the Autodesk Simulation team, and in this episode of Simulation TV, I'm very excited to talk to you about Autodesk Simulation 360, the migration of simulation into the cloud. So let's start with what is Autodesk 360. Well, Autodesk 360 is changing our customers' business model by providing a broad set of features, cloud services, and cloud-enabled products. Autodesk 360 is the hub by which Autodesk Simulation 360, Autodesk Building Information Modeling, or BIM 360, and Autodesk Product Lifecycle Management, or PLM 360, are connected. So it allows you as a customer to dramatically improve the way that you design, visualize, and simulate. We're democratizing these capabilities for you. And lastly, you can share your work with others anytime, anywhere with cloud-based storage and access. Okay, so what is Autodesk Simulation 360? Well, we've taken proven simulation technology and put it in the cloud. So we're providing you the best of both worlds. You have desktop ownership and you have cloud-based access of our best simulation tools. So Autodesk Simulation 360 connects to our design suites and to our optimization, energy analysis, and structural tools. But we'll focus on this for this episode on Autodesk Simulation CFD Motion, which is our highest level CFD solution, giving you flow and thermal studies, radiation, smoke, and also flow-driven motion and motion-driven flow, and our Autodesk Simulation Mechanical solution, which gives you linear and non-linear stress analysis as well as fatigue and mechanical event simulation. So why do our customers use simulation, and why do they use Simulation 360? Well, it's all about gaining a competitive advantage. So we've democratized simulation in order to level the playing field, and by using infinite, elastic, flexible, and scalable computing power within the cloud, we've placed optimization within the reach of the masses. It also lowers your total cost of ownership dramatically. So we're helping our customers reduce their capital costs and migrate to a more pay-as-you-go style model. So again, it's all about the access. And lastly, the experience and the access, being able to install and log in from anywhere is something that our customers expect and demand. So this gives you that capability as well. Okay, so what is infinite computing power and optimization in the cloud, and what benefits does it provide you? Well, it gives you the ability, historically, our customers have run a single desktop simulation, looked at the results, run another one and compared them. Well, now you can run an unlimited number of design scenarios simultaneously. So you're essentially stopping the clock on time to market or time to project completion and evaluating an unlimited number of designs, choosing the best one and moving forward. So one of the most common questions we get is, how is my data protected? So of course customers want to understand what type of protection measures are in place to protect their intellectual property. So there are three main pillars, and I'll cover this at a high level, and then we'll have an additional episode that covers security in detail. But the first pillar is informational security. So this is how we protect your data while it's in transit, moving to and from the cloud, and also how we safeguard any static data that's stored on the cloud servers. With simulation, none of the data is stored on the cloud servers unless you choose. The second pillar is physical security. So this relates to the physical safety procedures for the building. So it includes protection from theft, vandalism, and natural disasters. And the last pillar is operational security. So it's procedures in place to monitor anyone who has access to the cloud server. So there are very strict security protocols that they have to follow. And ultimately, we're using the ISO 27001 standard, which is the exact same standard with audit capability that banks and lending institutions use. In addition, we're using the HTTPS secure protocol. Okay, so now let's look at some customer use cases and understand why our customers use simulation. So on the manufacturing side or product design side, it's all about the upfront manufacturability. So if we look at this graph, this bar chart, as we go from left to right, the cost of design changes increases logarithmically. So we want to enable our customers to make design changes upfront and early in the design process when they're the least costly and the most impactful. So let's take a look at a specific example now. This is a linkage gear which translates rotational motion into linear motion. And in this case, Simulation 360 can be used to run many different design studies on this very computationally intensive type simulation simultaneously. So historically, again, we'd run one at a time. Now we can look at different materials, different designs, different rib sizes, and even different speeds and frictional loads to make sure that our design performs as expected. How about on the electronics side? In this case, we can use Simulation 360 to understand the effect of different inlet or outlet placements, different fan sizes, varying the heat sink fin spacing or heat sink material, evaluating different chips, and placement of components within the box. So we're using Simulation 360 to evaluate wildly different design concepts and drive down the junction temperature of the chip to increase reliability and reduce risk. On the industrial machinery or flow control side, we can look at pressure tests or burst tests of valve assemblies, or look at stresses on pump components. So in this case, we're using the cloud or Simulation 360 to study the effects of different pressure loads on the fluid moving through here and different wall thicknesses or different material types, and maybe even evaluate the effects of erosion as well. So that's more on the manufacturing and product design side. Well, how about our clients who are working in the built environment or designing facilities, water holding tanks or storage facilities, or even providing services to their clients? So they use simulation to examine innovative approaches quickly at a very low cost. At this scale, it's impossible to build and test, so digital simulation is the best method for optimization. They also use it for high-performance, sustainable building design, so whether it's saving on ventilation costs, increasing safety, mitigating environmental impacts, or even maybe looking at seismic or wind loads on a building or facade or curtain wall, simulation is very useful for them. They also use it to win more bids, so when they go into bidding competitions, they'll differentiate themselves with this core competency and this technology. And lastly, maximizing the value of the 3D modeling investment they've made. So no matter what the BIM or CAD tool they use is, they'll use simulation to recycle or leverage that data. So here are some more specific examples. This is the financial district in downtown Manhattan. And in this case, we could use Simulation 360 to look at varying wind speeds or even wind directions. So if you look at a windrows, there are several prevailing wind directions and speeds for each, throughout the year. So we want to look at maybe the top 3 cases and understand the effects on the buildings, pedestrian comfort, if we're going to have any high pressure loads, and maybe the loading on the walls. So here's a curtain wall, maybe that's on one of those buildings. So in this case, we'll use 360 to run a fairly computationally intensive study on several different designs simultaneously, right? So we're pushing all of that computing power up to the cloud to rapidly simulate this. So in this case, we can look at the structural effects of the wind loading on this particular design. Okay, how about in factories? In factories, we'll use 360 to look at different ventilation setups or vent or diffuser or supply grill placements. We want to make sure that we're properly ventilating the space and not over-ventilating or under-ventilating certain areas, and that we're mitigating any contaminant or pollution effects as well. How about in the healthcare industry? So hospitals and clean rooms face some fairly common challenges. They want very predictable laminar airflow. So in this case, we can look at different diffuser placements or designs, different filter setups, and different patient locations or different manufacturing processes and how the equipment affects the airflow. So again, studying those simulations simultaneously using the power of the cloud. And how about data centers, right? So mission critical data is stored in data centers around the world. We want to use Simulation 360 to reduce our energy consumption and minimize our redundancy while still maximizing the factor of safety of our design. So ensuring that we have cooling air provided to the server racks that need it the most. And lastly, here we'll look at a smoke study. So again, very computationally intensive to study a fully transient smoke scenario and understand how the ventilation system or the makeup air system as it turns on will perform and how it purges the space of smoke. So again, very computationally intensive simulations. We want to send this to the cloud, and maybe we'll study different makeup air system sizes, different capacities, or different fire locations within a building, subway, train station, etc. Okay, so that pretty much concludes the high-level overview of Autodesk Simulation 360. It's fast and accurate, it's flexible, it's affordable, and it's secure. So again, we're providing those flexible, scalable, infinite computing resources to you. We're also providing the desktop ownership of the tools and trying to really change your business model and allow you to effectively simulate and bring products to market or bring building designs to completion as quickly as possible. If you have any additional questions, feel free to reach out to our team directly. And thanks for your time.